In this video, we'll go through a few more techniques that involve using custom UI interfaces and database interactivity. So the first little piece of the application here is a coin toss demonstration. If you see in F12 in the console, we can watch which images are being shown and follow the full history. We've got a coin toss grid here, which we've used to upload images. And got a little calculations grid, which is just a standard no-code Jam.py grid. And there is a calculation that's used to compute the difference between the start date and end date columns. So we can add a start date and pick an end date. You can see the difference in days between those two dates is automatically computed, and that's saved to the database. And we've got a little cash register receipt application. This is a master details set of tables. So we have cash register receipts with a customer name and a timestamp. And for each of those records, we have a number of items which have been purchased. And you can see the item price, quantity, and quantity price along with tax calculated. And that total is displayed down at the bottom along with the total quantity count. And finally here, we've got just a bit of a simple custom form. And in the last video, I went through a lot about how to integrate custom user interfaces on the front end along with custom code on the back end. I wanted just to provide a little bit of a simpler interface to show how really easy this can be to do in Jam.py. So we've got a HTML form that was generated using a little visual builder. And when we entered text into this and values into this, we use, for example, paul@paul.com. Password of Paul, say he's a male, and his option is number 1, and his date is February 22nd of 2025, and we'll say his number is 23. Now, when we submit that, you can see that we have a little table here. This is a standard no-code grid created by Jam.py without any code at all, and you can see that the values we've entered into that custom UI have been saved into the form here. And of course, we can use this grid to edit the values in the database. So let's take a look at how we build each of these little pieces of the application. So the coin toss, there are a number of tasks here. These tasks are like pages in the application. They're added to the menu on the top. The coin toss page, it has a table associated with it. There are 2 columns in the table, an image column and an image name column. The image column is an image type, so it's going to upload an image for us. And the image name is just a text column of up to 100 characters. Okay, so when we just open that page, the coin toss page, we see a standard grid. And you've seen a lot about how to create these grids in the previous video, so I'm not going to go too into it. But what's important with this is that we can upload an image. So we can upload any image here. Let us go ahead and upload new images so you see this. On our server, we have 3 files there, a heads image that was uploaded earlier and a tails image and another image which has been soft deleted from the grid. It's no longer showing. So that's what we're seeing here in the list. I'm going to go ahead and upload another one right now just so you can see how this works. We'll upload the image for Pete Peterson. And this is not actually a person named Pete Peterson, but I'll use it here. Okay, so now you can see we've got another image added to the table, and that has been saved. If we look at our directory on the server, you can see that that is saved in a folder called static and a subfolder called files on the server. That's within the project directory in this little project directory we have called Jam form. So um, the files get saved there, and we're going to use those in our custom HTML. So really the whole point here is this is sort of like an admin. You can imagine a lot of applications you want to have access to a database and then provide a separate user interface. So here our admin interface is this little grid we're using to upload images, and then we're making use of those images in the coin toss UI. And so here when we click the flip button, what's happening is we've added another page called Coin Toss UI. And on that page, on that task, there are no tables associated with it. There's nothing else on this page except a little bit of client code. And what we're doing here, you've seen this a bunch of times, we're importing some HTML, a little template. So let's look at our task option here, click on our index HTML for the application, for the whole project. And you can see I've got a little custom class down here inside these two divs. This is called coin toss, which we're going to import into the page. And let's just take a really quick look at that. We've got a header, which is called coin header, and that just has a little bit of text in it. And then we've got another little div here. I don't really need the div, but just to separate it a bit, inside that div, we've got an image tag, which we're calling coin image. We've set the height to be 159 by 159. A line break, and then a form that just contains a button. And the idea of that button is coin button. So of particular interest here is the coin button and the image, which has the ID coin image. So let's go back to our coin toss UI. So this is the JavaScript which is being run when we open this coin toss UI page. First thing we do here is what you've seen a bunch of times already. We're going to find that coin toss class, and we're going to empty the current form so we're not showing a grid or anything else. And we're going to append that template, the coin toss template. So that opens up the HTML. And then we're going to attach to the coin form submit event. So when that button is clicked, when it's submitted, we are going to run this code here. So first thing I'm going to do is just prevent the page from refreshing, which is the default action for a submit. That just keeps the page loaded. And I'm going to find a little bit of a list, and this list is storing the folder locations, the folder and file locations of the images that we've uploaded using the default grid builder. So we've got the names of the two files, the locations of the two files on our server, and then we're creating a random value, and we're selecting from the image the random value, which is one of two images, the length of the list. If we had more images here, we're selecting from a larger list of values, this would just select a value from within the length of the list. So we're either getting this first or second item for the list, picking that value, and then we are setting the image attribute, the source attribute of the coin image tag to that randomly selected file path. And then here we're just also putting a little output into the console log, saying flip to and giving the name of the file location of the image. So that's what we see when we run this. Flip, and if we click F12, we see those console outputs. Okay, so that's how we do that. We have a admin interface to upload images that we need, and then we've got a separate user interface to make use of those images. And I'll just talk really quickly about how to sort of work with this interface and use the console, the F12 console, developer console, as a helpful bit of uh, the IDE here. So you can see here, I can type in values and access the database values and all of the other values in the Jam.py builder right here in the F12 console. So if I type in task, and look at uh, coin toss, you can see we've got a automatic um, complete. We're going to see what is available in that task. One of the things which is available in that task is the image column. You can see here, we've got some values here. We can kind of look through that whole object. And if we want to actually see what the value is for the currently selected object, let's go back over this page. So the currently selected object is the heads object. So let's get the value of that. You can see the value here is the file name. If I select this, do it again, select the tails object. Now you can see we've got the file path for the file name for the tails image, and we can interact with that database. Let's just do this. We'll go first. This will allow us to work with the first image, and from there we could get any information we need to about it. And we could also do next. And you see, it got really nice autocomplete here built in. So select next. And you can see it has adjusted the selection. And we also have functions like prior and last. We can step through and look at images and look at values in any of the databases just by clicking at 12 and F12 and in the console, looking at any values in any of the tasks, any of the objects in any of the tasks. That's really, really helpful for sort of working live with the objects that are in your project. Makes it easy to work and develop code directly in the browser, and then you can put that in code in your application. So another really useful tool that happens in the browser in Jam.py. Okay, so I think that's enough there to just kind of explain how you can interface with those values. Use JavaScript to pull out images from the database, or images which have been uploaded using the database system. Okay, so let's take a look at this next little application here. And in this grid, we've got a couple columns. Start date and end date. We could compute the difference. So let's see how we did that. In the application builder, I'm going to go back to our journals, and you're going to see there is a calculations task or a calculations page. For this, we have a little table associated. One column is called difference. That's going to store an integer value. And then we have a start date and end date column. Now, those both store date values. That's all there is for the database there. And in the client module, very simply, we've got a couple of event handlers. First thing we're going to do is evaluate this thing, semicolon. We're going to evaluate any changes. So when any field is changed, we're going to run this function. We're going to take the field and look for the owner of that field, which is the row, the table. And so we're going to look at this owner, the table, which contains that field, and we're going to look in the difference column, that row, and we're going to get the value from it, or we're going to, set the value for it. And what we're going to set it to is the end date value in that row minus the start date value. And that's going to give us milliseconds. So we perform a little calculation, divide that by 24 hours in the day, 60 minutes, 60 seconds, and 1,000 milliseconds. So that number will convert this to a number of days. And so that's run anytime we change a field value. So if we go up here, refresh this, since I did make a change there. Calculations. And let's just change a date here. So now we are now activating that event. We have made a change, and you can see the calculation changes. Okay, so fairly simple. And there is another function here. It's a validation function, which we can use whenever we enter a value. We can perform any sort of computation we want. Here we just have a little if conditional, and we're saying if the end date is less than the start date, then we're going to return a little notice here saying the end date must be later than the start date. So let's do that here. We'll change this to, say, 1/27, and we get that error. End date must be later than the start date. So let's fix this up. Put this back over here. And you can see that validation works. So those are some really common things that you're going to need to do in just about any sort of application. And we'll use that same sort of calculation again in the set of calculations here again in this cash register demonstration. Okay, so what we've got here is a master details set of tables. And again, we're performing some calculations and entering some values and doing some validation. So you can see here when we add a new, let's click on this. When we add a new receipt, new and edit buttons up on top here. Let's add a new item to this receipt socks. Let's see, these are $7. And you can see if I perform this change, there is an event there for a calculation, and it performs the calculation and adds the tax, and that's added to our total receipt, and the totals are shown down below, the total quantity of items and the total price with the tax. Okay, so when we do that, back to our application builder, and you can see we've got a cash register task, cash register page. And what we're going to do is take a look at this. We've got for the main journal, all we're doing is storing a timestamp, which is a date time, and a customer name, which is text up to 300 characters. Okay, but importantly, for that cash register receipt page, we do have a details table. So let's take a look at the details tables here. We've got a cash register detail page, and here we have a table that contains 3 columns: a price, a quantity, and a third column called quantity price, which is the quantity times the price, or what we'll use for the quantity times the price. Okay, so that is set up as a detail of the cash register journal. So I've taken that detail and moved it over here. So we're using that detail table as a sort of subtable of the cash register journal. Okay, and we look at that cash register journal, we've added into the journal form the view detail. And that is the cash register view detail. I've also added that into the edit form. So both on the main view form and on the editor form, we're seeing this detail table. So just to be clear, we have the details shown here, and we also have the details shown in the edit form. Let's refresh that. I'm not sure what it changed here, but let's take a look at that receipt again. And if we click edit, so you can see that we see the details there, and we also see the details here where we can edit them, add new details for each separate cash register receipt. Those receipts are tied to this main journal. So we get a receipt for each of the users, and each of those receipts has a multi-row and multi-column table associated with it. Okay, so take a look here at what we did. Very little code to do all this. We're going to look at the details table, look at the client module, and actually take a look at this again. Up here, client module. There we go. So in our client module, in the imported details table, we have the same two kinds of functions that we had in the previous example. We've got a validate function. So when a new value is entered, we're going to check to see if that price value is less than 0, and we'll give a little error for the user to see, a little notice for the user to see that the price must be positive. And otherwise, if the field gets changed, we are going to set this quality price column value to the value of the price times the value of the quantity fields and multiply that by 1.06 to represent the tax value. Okay, so we can see when we use this, if we, let's just edit one of these. I need to refresh here since I made a change. This again, cash register receipts, and let's just make a change here. And if we try and do, for example, let's change this socks value to -1, and it's going to give us that error. Price must be positive. Okay, so let's do this and change that to, we'll say it's $5. And you can see as soon as I make that change, it computes the price times the quantity and multiplies that by 1.06. Okay, and so we've got that's simply a very nice cash register receipt application that performs all the calculations we need. And just to be sure this is clear down here, the way we're getting the final total is in the journal, in the cash register journal, I should say, actually, I think it's here. To look for this really quickly. What we're actually doing here is adding some summary fields on this detail. And the fields that we want summaries on are the quantity and the quantity price fields. So what we're doing is every time that detail view changes, we're performing that summary down here. And of course, we can interface with the with those fields using JavaScript, but for now, that's a built-in feature in Jam.py. It's just totaling up those fields. You don't have to write any code to do that. Okay, so a couple more things here. We have also in this little application a custom form. And we did a lot with this in the last tutorial, but I want to just kind of show you how simple it can be. We kind of dove into using SQL Alchemy and doing things in the back end, but Jam.py makes it really a lot easier to do all that. So you've seen here we have a form. Let's refresh this. I keep making changes to the code as we do this tutorial, but this code, and I just want to kind of briefly show how this works. I built this using this is really easy to use visual layout editor called grapes.js. Now, grapes.js is an open source visual builder. You can build your own version of grapes.js. In fact, I have one right here. This is just an HTML file. It doesn't require any database. It doesn't require anything other than just a browser. You can build your own version of HTML builders, and you can put in navigation panels, and you can put in all sorts of components like maps, and you can put in grids and add columns, you can add pages, and the navigation works between those pages. And this is all free. And one of the things I did here was I created a little um, set of default forms, one of which has everything that we actually used in our um, application here. So I'm going to just copy that multi-input form down here so you can see. And Jam.py lets you download that code, and then you can see that code. You have the HTML that's available for that. Really nice, simple little builder that you can do a lot with. And the really great thing about this, they have a little hosted version that you can use, and it's free for the most part. But I showed this in the last tutorial. The really great thing about it is that it lets you do all these things that you normally have to write a lot of CSS for. So you can change the layout and use flex boxes and change the size and the topography and add all sorts of typical components. So it's a really easy to use, simple editor, and all you need to do is download your code, and it will give you all the code you need. And typically we're looking just for everything that's in the body, collecting all of that. And so I used my little builder here to build this little form. So you can see all I have is a little header, some text, and then one of these forms that I included. And I didn't even bother in this one to copy the CSS. What I have here, go above here and look in our templates. And so this particular template, it's a simple little template, which I called, give the class name custom form. Okay, so we have custom form here with some padding. And if we look in our CSS for the entire project, the whole project, this was the CSS that was created by the Grapes editor. Could use that if I wanted, but we don't need all that. All I wanted to do was add a little bit of padding to the custom form, because if I don't, it looks like this. It's very tightly pressed against the edge. So if we add that one little bit of CSS, set the padding to 20 pixels, now when we look at that div, it's got a 20 pixel padding value. So very easy to create these forms, and all I've done here is use the stock HTML that I got from grapes.js. And you've seen this a bit. I just want to show you a little bit about how this actually works when we want to interface with the database in the simplest possible way. Let's take a quick look at this. We've got a header here. We've got just a little bit of text. That's all the text you see there. It's actually quite a bit of text. And we got a form. The ID for the form is this. Grapes.js creates these unique identifiers, so you can typically import a bunch of forms, and you will safely have unique identifiers for everything in the application, everything in the layout. We've got some input tags. So we have a multi-text one, which is the thing that we will enter text into. The little tag will enter text into, and then there's an email input box, and then a password input box, and then we have a couple radio buttons, and then we have a multi-select drop down with a couple values in it, and here we have a date selector, and we also have another input that allows us to enter numbers. So this is all just very basic HTML. The key thing is to look at the IDs here and the class name of the form, because that is where we're going to get all the values that we're going to enter into the database. So if we take a look at our application builder and we go back to our custom form now, so we have on the page, on our application, we have a form table and a custom form. So to be clear, this database table was created using the default no-code builder in Jam.py. So you think of this again as maybe an administrative backend for the table, which we could show and hide from unauthorized users, or this could be another interface for users to interact with all of the data that's in that table. So in this table, we have a bunch of columns: date, email, gender, number, options, password, and text. Also email, date, and created at. So you can see the types that they contain. And then there is no server module for our custom form. Our custom form only has client code. So we can interact with the database entirely using this little bit of code. Okay, so what we're going to do here is, we've seen this before also on when the view form is created, we're going to run all this code. What we're going to do here is, first thing you keep seeing over and over, to create a custom user interface, we're going to clone in that custom form class, that the whole template that we got from our builder, our HTML builder. And then, now that is showing, we've emptied the regular display that is displayed by default by Jam.py, and we've appended this template. And then the next thing, we're going to handle the submit event for this form. So let's look at that again over here. This form is called, where is it? IFv3g. And so here, again, we're going to handle the submit function, the submit event. This is the function that runs when the submit event is fired. So when that button is clicked, first thing we're going to do is prevent the page from reloading. And then we create a variable. And this is the key here. That variable refers to the form table that we've created with the application builder. That is this task, which includes a data table. Okay, and we're going to copy that. And the reason we copy it is because in a web application environment, you can have a lot of users accessing the database. So we want to make a copy of it while we work on it for each user. So this happens in the user's browser. This is a JavaScript that's running in the user's browser. First thing we do is copy that task and assign it the variable C. So now you can see we're going to do a bunch of things with that variable C. First thing we're going to do is open the database, and then we're going to append a row to the database. And then for that current row, we're going to set the text column value to the value in the form that's labeled by that ID. And then the email value gets set to this value in the form, password value, and so on. Gender value, this is how we get the selected value from the dropdown, and how we select the selected options. I should say not the dropdown. This gender value is a bunch of radio buttons. And then get the date value, and we're doing a little bit here to make sure that the date is in the correct format, and so on. So all we're doing, very simple, to use the database from any page or task in the application. Again, be very clear that what we're doing is grabbing the form tables task, where we have this table defined, where we've used the no-code builder to build a data table. And then we're opening it, appending a row, and then setting all the values to the values that are in that form. It's that simple to do this with Jam.py and to use a custom interface to interact with the database. And then we post and apply those changes. And that's it. That's how we bring in this HTML form that we can use a visual builder, or just as easily use generative AI, use ChatGPT or Claude or Gemini or DeepSeek to create code like this. This is standard HTML code. Just make sure that everything has an ID, and then you can refer to the items on the page. So we've done a little bit to take values from a page, and we've done a little bit to add and change values on a page. In our coin toss, we added changed the values on the page. Again, by referring to the items on the page. So here we changed the coin image, changed its attribute. So we can go both ways. We can get data from the database and show it on the page, and we can take data that's on our custom page and put it in the database and perform computations, and we can combine that with all of the no-code grids and forms that are built into Jam.py. So hopefully this gives you a little bit more of an idea about how to extend Jam.py, so you can do basically anything you need with it and still use all these really productive features that are built in to deal with the database schema, to build database schema, to build grids and user interfaces and forms very, very quickly. There's not much of a faster, more productive way anywhere to do that sort of work and to make it accessible to users who don't have any coding experience. So this opens up a lot of doors to allowing users to build their own schema, interact with schema, and build their own grids so they can work with their own database tables. And then if they need some special functionality, any web developer, any developer who knows a little bit of JavaScript or a little bit of Python on the back end can integrate any of the libraries, each of those really enormous ecosystems to get work done. So you can build your front ends and work with the data from the tables. I think between these last couple of videos, you should have a pretty good idea about how you can really build out Jam.py applications so they're custom. I'll stop there and continue with the next video.